Hey everybody! So you've almost made it through your first week of digital learning. I'm so super proud of you guys. You have done amazing. Some of you, by the time you get this, will have made it through your first week. You're doing awesome. You're doing awesome. So keep it up. What I did notice is that a lot of people were having questions about the study guide, and there were actually a few things on the study guide that we did not get to in class because we got cut off. So we're going to go through some questions on the study guide a little bit each day. Once we've been through things on the study guide, I'm going to have you go ahead and take the test. So the test is available, but you don't need to take it right now. All right, so let's jump right in. So the first thing that we're doing is just going back and rewriting logarithmic equations as exponential equations. So that doesn't mean evaluate them. We're not looking for a numerical answer. What we're looking for is an exponential equation. So an exponential piece of the equation. So I know just by the structure of this log function that 2 is going to be my base. So 2 is going to become my large number. I know that this number here is my exponent, so 2 to the 4th power, and that leaves my x, my argument, going over here on the other side. And that's it. We could evaluate 2 to the 4th power and find out that that's 16, but that's not what the question asked. The question asked to rewrite the following as an exponential equation. So don't even worry about putting it in your calculator or anything. So going on to this one right here, I don't have a base. There's no base there, but remember, when there's no base, the default base is log base 10. So 10 is going to be my base, 39 is going to be my exponent, and that leaves x going over here on the right side of the equal sign. Now, the natural log doesn't have a base written down, but the default, the only base for natural log, not even the default, there's no other option. The base for natural log is like saying log base e. So that means when I change it into an exponential function, my base is going to be e. This is my exponent still. Everything else stays the same. Okay, now I could leave it like that, or I could go one step further and get the x all by itself and make it e to the 14th power minus 2 equals x by subtracting a 2 from each side of that equation. Okay, so on your test, most of these things will be multiple choice. If not, I'm grading them, so don't worry too much. If you left something like this just as an exponential equation, I would accept that the same as I would accept that over there. All right, so now we're going to write the inverse. So third period got to work on inverses a little bit. You all are going to love this because it's a lot easier than what we did in class. 6th and 7th period, we were supposed to do it on Monday, and then we weren't in school. So inverses are super easy though. You guys, you have this. So with any inverse of any function, the first thing you're going to do is switch x and y. So always, always with an inverse, switch x and y. And that literally means rewrite the equation, and wherever x is, put y. Wherever y is, put x. Next, I'm going to solve for y. I'm going to get y all by itself. So I'm going to go back up here to what I did. And I could just say, okay, I know my base is 2. That means 2 to the x power, because that's my exponent, equals y. I'm going to show you a different way to do that. This is the answer to that question. So this 2 to the x power equals y is the inverse of log base 2 of x equals y, but I want to show you another way to do this because it's not always this simple. So sometimes you have to take your, so say your log base 2 of y equals x, and you actually have to do an inverse operation. Just like if we were adding something, you'd have to subtract. Here we have to do the inverse of logs, which is exponents. So I'm going to take my base and I'm going to make it nice and big under each one of these so that these two things now become the exponent on a base of 2. Now my log base 2 cancels out, and what I'm left with is y equals 2 to the x power. So it's really simple with an equation like this one to just say, oh, well, I know that's the base, that's the exponent, but if they were a little bit more involved, sometimes you actually have to solve them. All right, so once again, we have a baseless log, which means this is base 10. So the first thing I'm going to do is flip-flop my x and y, and I'm going to get log y equals x. I have a base 10, so my base is 10, x is my exponent, and y is the product. If you want to see it this way, we would make 10 our base, our log base 10 and our actual base 10 would cancel out, and we would be left with y equals 10 to the x power. All right, so our next problem is the natural log, and here we have natural log of x plus 2 equals y, so I'm going to switch my x and y. That gives me the natural log of y plus 2 equals x. I'm going to go ahead and use this kind of longer method here because I've got a y plus 2 in there as well. So I'm going to raise both things. I know the base of natural log is e, so I'm going to raise both, or make both of them exponents with e as the base. My natural log and my e cancel out. And what I'm left with is y plus 2 equals e to the x power. I go ahead and subtract a 2 from each side, and that leaves me with y equals e to the x power minus 2. Okay, you guys, I don't know what happened in the last video, but I missed recording this whole last problem, and this is like the 4th time I've tried to do this, so I'm just going to explain to you what we did. Okay, so this last question is asking you to graph the inverse. And even when graphing, you're still going to switch your x and y coordinates. So the first thing I have to do is identify the asymptote. Well, the asymptote, remember, is the line that a graph approaches, or the point, it could be that a graph approaches but never reaches. So this one I can see kind of looks like it evens out at x equals -1. So I put that here as my first part of that equation, or first part of that statement. My original asymptote was x equals -1. I'm literally going to change this x into a y and rewrite an equation. So in this case, y equals -1 is the asymptote of my inverse. So that's what I drew here. Here's my line at y equals -1. And since you're taking this test online, really what you're going to need to be able to do is take a graph and say, yeah, this is the graph of the inverse. I see that its asymptote's in the right place, its points are in the right place. This is the graph of the inverse. So now my points. So I identified a point right here at -0.5, so -1/2, -1. So that's this point right here. So in order to find the corresponding point on the inverse graph, I just switched my x and y. So my new point for the inverse is -1, -0.5. Now my second original point is over here at 3, 2. So 3, 2 was my original point. I switch my x and y, I end up with 2, 3. So now I also noticed that this graph goes through 0, 0, and 0, 0, if you switch it, is still 0, 0, but that helps me kind of get the shape of my graph right. So here's my 2 points. This is my point at -1, -0.5, and this up here is my point at 3, 2, or 2, 3. And then I kind of use the 0, 0 as well. My graph approaches this line down here, but never crosses it, and make sure that it goes up here through these points that I've drawn. So if you were to draw a graph like this for me, all I would really be looking for is that you've got your points that you picked in the right spot. You have the basic general shape and you have your asymptote in the right place. And then to answer the question, is the inverse a function? We have to remember what a function is. A function is any equation that for each input, you only get one output. Now you can repeat outputs or repeat inputs, but what happens with the graph of a function is that if you were to draw just random straight lines, vertical lines through this function, it would only touch the function in one place, each line. If you look at something like the graph of y equals the square root of x, that's a sideways parabola. A vertical line, only if you drew a vertical line right through here, that would hit in one spot, but every other vertical line you draw through that is going to hit the graph in two spots. So this is not a function, but up here, this graph that we have created as well as the one that we started with are both functions.